Hello students, in this video we'll discuss algebraic rules for differentiable functions. Let's suppose that f and g are differentiable. At x equals c. Our first rule is that f plus or minus g is differentiable at c. With f plus minus g prime of c equals f prime of c plus g prime of c with a plus minus. So in other words, if you take the sum of two differentiable functions, if you want to do the derivative of the sum of two functions, it's just the sum of the derivatives or the difference of the derivatives. Okay, great. 2 is called the product rule. It states that f times g is differentiable, and it states that f times g prime at c is f of c, g prime of c, plus f prime of c, g of c. That's the product rule. There's the quotient rule, and the quotient rule assumes that g is not equal to 0 at c, right? So this is the quotient rule. And the quotient rule states that f over g prime of c is g of c, f prime of c, minus f of c, g prime of c, over g of c quantity squared. And the key assumption here is that g of c is assumed not to be equal to 0. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. That's the quotient rule. Let's give some proofs of these things. So let's first prove the additive rule. So here are a couple different proofs of these things. So let's prove the additive rule. Let's prove 1 with plus. Okay. So I'd like to compute the limit as h goes to 0 of f of x plus h plus g of x plus h. That's f plus g evaluate x plus h minus f of x. No, of course, we're doing this at the point, we're assuming it's at the point c, so we have to change these x's into c's over here. So those would be at the point c, right? So we're going to do everything at the point c, because we're differentiable at c, at c, at c, and then plus g of c, all divided by h. Well, of course, we can break this into two limits, right? We can break this into the limit as h goes to 0 of f of c plus h minus f of c over h, plus the limit as h goes to 0 of g of c plus h minus g of c all over h, since both those limits exist by the fact that f and g are differentiable at those points. And of course, we see this is equal to what? This is equal to f prime of c plus g prime of c, and that gives us the proof of the property 1 with plus. With minus is exactly the same. Now let's do the next proof. Let's prove the product rule. So here's the proof. Let's do the proof of 2, the product rule. Okay, we're going to prove the product rule. Okay, so I have the limit as h goes to 0 of f of c plus h, g of c plus h minus f of c times g of c all over h. That's what we have. That's the term we have to estimate over here. And so now what we're going to do is we're going to add and subtract in a term on top over here. What we're going to do is we're going to add and subtract in plus minus. That won't affect anything if I add and subtract the same thing. I'm going to subtract in f of c plus h times g of c. Okay? Now, I'm going to break this into two limits now. What I'm going to have is this is going to be the limit as h goes to 0 of, I have an f of c plus h and an f of c plus h with a minus sign over here. So I'm going to factor out an f of c plus h. And then I'll have a g of c plus h minus g of c. So that's g of c plus h minus g of c. All divided by what? All divided by h. Then the second part I'm going to break that into is I'm going to have a plus f of c plus h and then a times g of c. And so from those two terms, I'm going to factor out a g of c. So plus the limit as h goes to 0 of g of c times what quantity? Times g of c, then we have an f of c plus h minus f of c all over h. So in other words, I break up my two terms by adding and subtracting. I know that both these limits exist. Let's examine why both these limits exist. The second limit over here, g of c is just a constant. So g of c is that is just constant, and then the rest of the limit exists by the fact that f is differentiable. Now this part over here exists because g is differentiable, so that part of the limit exists. And since this term depends on h, but we know that since f is differentiable at c, it's also continuous at c. So as h goes to 0, this will converge to f of c. So all total will happen. All total, we will see that this is equal to this first two terms over here. This first term is equal to f of c times g prime of c. And these terms over here in the bottom will converge to plus g of c f prime of c. And that is the proof of the product rule. Thank you very much.